This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the February-March 2021 A-level, AS level, like you could say, paper from Cambridge 9709. This is a variant. Well, there's only one variant for this, 1-2 for February-March papers. So it's a paper from 2021, question number 4. One of my students has asked me to answer this question. It's quite a straightforward question, but it has a lot of information here which needs to be understood. So first of all, it says a line has equation y equals 3x plus k. And a curve has equation y equals x squared plus kx plus 6, where k is a constant. So k is just a number. Find the set of values of k for which the line and the curve have two distinct points of intersection. Two distinct points of intersection. So when you have a quadratic, this is like a smiley face quadratic, something like this. And you have a straight line. This is a line with a gradient of 3, which has this type of, something like that. Okay. There are a number of different scenarios that we can have. You could have the curve and the line in such positions such that they will never ever meet, like this. This curve is going to continue going up. It's going to continue going up. This will stay exactly as it is. It's a straight line, same gradient all the time. So therefore, they will never meet. Or you could have a point where the curve and the line touch such that the line is a tangent to the curve, where it just touches at one place. That's where you have what's called one real solution, or it's called a repeated root, which you'll understand more detail when we sketch graphs. And the third scenario is where the curve and the line, they intersect in two distinct points, like this. Two distinct points. There are two places where they intersect. Okay, and that's the case that we have to consider in this question. So when we try to find where two functions intersect, then we try to solve the equations simultaneously. So we have y equals 3x plus k, that's the equation of the line, and y equals x squared plus kx plus 6, the equation of the curve. So when you're solving them simultaneously, what we try to do is substitute one equation into the other. Okay, some people say equate them with each other, which kind of works in this case. That's fine, right? That's basically y is equal to this and y is equal to that. They're both equal to each other, equate them. But it doesn't always work like that, right? Sometimes you have an equation in x and y, like x squared plus y squared, like circle equation. So you don't just equate them, it becomes a bit weird. Now you substitute one equation to the other is a better way of thinking about it. So what I'm going to do here is I'm going to take this y and replace it by what y equals in the other equation. It's like substitution. I'm going to substitute instead of y, this. So I have x squared plus kx plus 6 is equal to 3x plus k. Now, to solve this equation, if we were going to solve it, we would normally make it say equals 0 first. So we're going to say x squared plus kx minus 3x plus 6 minus k. I've just kept the x terms and the constant terms together. Remember, k is a constant. So that's equal to 0. Now, in order for me to work out what my coefficient of x is, I'm going to factorize this. So I have x squared plus, this is going to be x times k minus 3. And this is the constant. 6 minus k is a constant, equals 0. So again, to make it very clear, I'm going to write x squared plus k minus 3 x plus 6 minus k equals 0. So this is my coefficient of x squared is 1, the coefficient of x is k minus 3, and the constant is 6 minus k. Now, if you were to solve a quadratic equation by using the quadratic formula, for example, you would have x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Now, this part, which is underneath the square root sign, is a very, very important part of the quadratic formula, because it helps us to discriminate between how many solutions there's going to be. All right, that's why it's called the discriminant, because it discriminates between how many solutions this equation is going to have. Right? So basically, if b squared minus 4ac is a positive value greater than 0, you'll have minus b plus or minus some value over 2a. So you'll have minus b plus something over 2a and minus b minus something over 2a. You will end up with two distinct solutions, two separate different solutions, which is our case here. This is the case we're looking for, two distinct points of intersection. So this is what we're looking for. But I'll just explain the other conditions as well, and then we'll go on to answer this question. So we can also have b squared minus 4ac is less than 0. In that case, what's going to happen here is you're going to have something that's undefined. You'll have a square root of a negative number, which doesn't give us an answer. It doesn't give us a real answer. So for now in AS, we will just consider this as there's no, we'll say no real solution. That means they will never intersect. When this is the case, they will never intersect. Okay? And the third case is when b squared minus 4ac, well, it's possible it could equal 0. In that case, you're going to have minus b plus or minus 0 over 2a. So you just end up with minus b over 2a, which just means there's only one answer. Okay? And that is going to be 1, and we normally call it a repeated root. Okay, one repeated root. So these are the three cases that we can see from this. The first case where they intersect in two distinct places. The second case where they don't intersect at all. The third case where the line is a tangent to the curve. That's when you have one repeated root, when b squared minus 4ac equals 0. So if the question said, find the set of values for k for which 3x plus k, or find the value of k for which 3x plus k is a tangent to the equation, to the curve, then we would say b squared minus 4ac equals 0. If they say, find the set of values of k for which the line and curve never intersect, then we would say b squared minus 4ac is less than 0. But in our case, it says find the set of values of k for which the line and the curve have two distinct points of intersection. That's where we have to consider where b squared minus 4ac is greater than 0. And that is our situation in this question. That's what we have to do. We have to take this and we should mention something like this in our steps, as we have two distinct solutions. Therefore, b squared minus 4ac must be greater than 0. Must mess up there. Must be greater than 0. Okay, so now in this case here, a is the coefficient of x squared, which is 1. b is the coefficient of x, which is k minus 3. C is the constant, which is 6 minus k. So we're going to set up this b squared, which is k minus 3 squared, minus 4 times a, 4 times 1 times c, 6 minus k, is greater than 0. So this, if you expand it, gives us k squared minus 6k plus 9, minus 4 times 6, which is 24, plus 4k is greater than 0. So let's combine the like terms. Minus 6k plus 4k is minus 2k, and 9 minus 24 is minus 15. That's minus 15 is greater than 0. Now, to solve, this is now a quadratic inequality. So it goes into topic of solving quadratic inequalities. Now, a lot of students, they mess up with this. They think you can treat it just like an equation and just factorize and say either this is greater than 0 or that is greater than 0, and that's completely wrong. You can't do that. Okay, you can't just factorize and say one must be greater than 0 or the other must be greater than 0. That makes no sense. Okay, so you have to do this in a particular way, which I'm going to show you now. So first of all, you do consider as an equation in order to find what are called the critical values, where this is equal to 0. Then we can decide when k has to be more than or less than something. So first we find when it's equal to 0. So we factorize. So we have k and k. 5 times 3 is 15, and 5 and 3, they give you a difference of 2. One of them has to be positive, one has to be negative. So we're going to have k plus 3 and k minus 5. That will give us k squared minus 2k minus 15. So that's correct. So we can say either k equals negative 3 or k equals positive 5. So now I want to find where this is positive, where this is positive. This is where it's 0, so we can find where it is positive in different ways. I like to use sketching. I think that's way easier and also because it's always good for us to be able to sketch something that's important for us to know how to do. So this represents the discriminant. This represents K. Now, remember, this is not drawing any function, not drawing this function. It's making a sketch of what is happening to the discriminant. This equation here represents the discriminant. We want to find when the discriminant has a value which is positive, which is on this part. So if we were to sketch this equation which represents the discriminant, k squared minus 2k minus 15, it's going to cross the k-axis at -3 and 5. So it's going to look something like this. It's going to cross at -3 and 5. And here will be minus 15. We don't have to worry about that in this. Now, where is the value of the discriminant greater than 0? Well, it's greater than 0 in this section over here. That section over there. When k has a value, for example, of -4, the discriminant is going to be a positive value. When k has a value, for example, 6, anything more than 5 here, it's going to have a positive value. And when k has a value which is somewhere between -3 and 5, the discriminant will be negative. So the discriminant is greater than 0 when k is less than -3 and when k is greater than 5. So our solutions are going to be, for this, that the set of values are when k is less than -3 or when k is greater than 5. You can write it in set notation if you want to. And k is such that, okay, or you can just write k is less than -3 or k is greater than 5. Those are the values of k which will cause us to have two distinct roots. If the question said, find the values or the value of k or the values of k for which the curve and the line meet at, well, in that case, it wouldn't come out like this anyway. Don't worry about it. But if it said, find the values of k for which the, what's what I'm trying to say? For which there is no, for which there are no solutions, then you'd put between -3 and 5. You say k between -3 and 5. That will be for which there's no solutions. Okay, if they're saying where there's one repeated root, it would be when this is equal to 0. Okay, so it would be k equals -3 and k equals 5. Okay, so there we have the answer to this this question here. All right, which is about quadratics, the discriminant, and how to find the values of k when there's two distinct roots. Okay, so I hope that was beneficial. Thank you for watching. Other questions from this particular paper will be found in the playlist over here. You might find some of my playlists are empty, and some of my playlists have just 1 or 2 questions because I'm just, starting teaching this Cambridge syllabus recently. So as I answer more and more questions, they will start to fill up. So you'll find questions from this paper. When I answer them, will go in this playlist over here. Questions from this topic of quadratics, you'll find in the playlist over here. You can subscribe to my channel by clicking on this link, and you can use this link here to find other material you might be interested in my channel. It tells you how to get there quickly. Thank you for watching, and see you soon.